Wave is the new software package for attocube's displacement sensor IDS3010. It enables fast and easy data acquisition, evaluation, and processing for various applications such as machine calibration, motion control, or vibration analysis of workpieces. This tutorial gives a short overview of the user interface and functionalities, and usage of the software tool. To start the program, open the folder with the Wave application and double-click the Wave icon. An overview screen opens, showing you all IDS devices connected with the network, which can be connected directly to the computer or as the sensor is equipped with the web server, remotely via network. By hovering over the field and clicking the left mouse button, you can name each device and axis individually. If a red warning sign, "No license available," appears, you have to activate the upgrade package to use the software in combination with the IDS device. Select the axis you want to activate for the measurement by clicking the check boxes. Then start the alignment mode by clicking the Next button on top of the screen. This could take a few moments till minutes. A new window opens up. It includes several measurement settings. In the field axis control, you can choose the desired measurement mode by clicking single or dual pass mode, while single pass mode is the standard. You can also select which axis should be the master axis of your measurement. In the MISC panel, you can activate or deactivate the pilot laser. The visible signal facilitates the course adjustment of the target. The pilot laser can be switched on or off during the alignment. The field streaming rate indicates the bandwidth at which the measurement runs. Wave provides a bandwidth of up to 1 MHz for one axis or 500 kHz for 2 or 3 axes. In this case, we want to capture data with a bandwidth of 250 kHz. The bar in the field optics alignment shows the signal quality per axis, indicating on how well the laser is aligned between sensor head and target. In this case, only 2 axes are selected. A value of 500 to 700% per mil is recommended to be optimal for a stable and reliable measurement. However, the measurement also works with a signal of 300% per mil. If the signal is strong enough, the measurement will be started by clicking the button Next on top of the screen. The starting process of the measurement takes a few minutes. The operation window opens and shows the displacement plot for each axis. The x-axis shows the chronological course of the measurement. As a maximum, a 5-second period of past displacement data is shown. The y-axis shows the target's displacement in nanometers. By default, the scale of the y-axis automatically adapts to the displayed data. If you want to change the axis individually, you can do this by either scrolling the mouse wheel up and down or by dragging the plot. The displayed time period will be zoomed in or out respectively. In case you want to adjust the displacement range of the y-axis, uncheck the AutoFit Y box on top of the plot. Move the cursor into the scale of the y-axis by scrolling the mouse wheel or dragging the cursor. The y-axis can be zoomed or moved. By checking the AutoFit Y box again, the y-axis automatically adjusts to the displacement. By clicking the FFT button on the top right, you can add a plot of the displacement over the frequency. New panels appear showing the fast Fourier transformation for each active axis. The data of the frequency analysis corresponds to the displacement measurements shown on the left. Zoom functions can also be activated in the FFT plot by checking or unchecking the AutoFit boxes and scrolling or dragging the mouse. If you use the Zoom function in the Displacement tab, the FFT plot will adapt automatically to the time interval that is shown by the Displacement tab. If the target is stimulated, the FFT plot displays vibration amplitudes with nanometer accuracy. In this case, we see a 200 Hz vibration. For a more specific analysis, the measurement can be stopped by clicking the button Pause at the top of the screen. Again, the plot can be zoomed in or out and specific sections of the measurement can be analyzed in detail. This mode also provides a more specific FFT analysis over a selected time period. To select the relevant area, move the cursor into the displacement plot, and then move it to the desired starting point. Now press the Control and the left mouse button and move the cursor to the wanted endpoint. The FFT automatically adapts to the marked area. As the plot shows, the stimulated vibration is approximately 5 Hz in this case. To end the pause mode, press the Continue button. Wave also includes the feature to save and export measurement data. For saving the data, click the Record button. A new window opens up. You can now save the measurement data into a wave-specific file with AWS extension. As soon as the Save button is clicked, the displacement data of all shown axes, in this case 2, will be saved in this file. The Record button will blink. To stop the recording, simply click it again and the data saving mode will stop. For exporting the measurement data into a CSV file, click the app Wave Export in the folder with the Wave application and select the file which was created by Wave. You can also open directly the AWS file in Windows Explorer if this file type is linked to Wave Export. A new window will open up. The upper row indicates date, time, and duration of the recorded measurement. You can now specify how and which data should be saved into the CSV file. In the field Sampling Rate, you can choose the desired bandwidth. If you want to save memory, you can export the file with a lower bandwidth. A sampling rate of 5 means that every 5th data point is exported into the file. In this case, we only want to export every 2nd data point. By default, the data will be split into files of 20 megabytes. You can individually change this size in the field File Size Handling. By pressing the Export As button, you can export the saved measurement data as CSV files. After the files have been exported, they can be opened in different programs such as MATLAB, Origin, or Excel. And it can be easily used for other post-processing tasks or calculations. In this case, we have opened a CSV file in Excel and plotted the saved measurement data via the Excel functions. Attocube's IDS3010 measurement software package Wave offers a time and displacement zoom, a FFT analysis for analyzing vibrations and overshoots, CSV export for easy data post-processing, and intuitive device overview and selection.